Hello guys, welcome back. This is your boy Combs the QGIS analyst. We are back, and today we've got something new for you. Alright, yes, the previous tutorial we determined the boundary of Kama Reservoir and some of these its important tributaries. Okay, so now we need to start doing some water quality assessments, and we're going to start with the surface temperature. We want to determine the surface temperature of this water body. Okay, we want to determine the surface temperature of this water body. All right, why is surface temperature detection very important? All right, detection of surface temperatures. Remember, an increase in temperatures can greatly affect our water bodies. We want to focus on. We want to see this area having higher temperatures because there is a thermal power station here. We're expecting human activities such as generation of electricity to affect water temperatures. All right, we're done with explaining. Let's get to the practical. All right, let's get to our practical. So what we're going to do first is to add a plugin that is called semi-classification plugin. So we're going to go to plugins, manage and install plugins. Alright, so we're looking for you just type SCP. So we're looking for this plugin. It's called the semi-automatic classification plugin. You need an internet connection to do this. So you say install plugin, then the plugin will appear here. As you can see, SCP, there is our plugin. So in order to determine the surface temperature of a water body using Landsat 8 images, this may not be the similar, we may not use the same steps if you are using Sentinel imager, but for Landsat imager, this is the step that you have to follow. So you're going to go to your plugin SCP and look for Preprocessing and go to Landsat. Okay, and then you go to the first thing that you need to do is to look for the directory that contains your Landsat 8 bands. So this is the folder which contains your bands. So you go there and look for the folder that you're interested in. So we're going to use an image, 2013 image. So this is the folder. Navigate until you get to the final folder. So this is the folder which contains our bands. The folder where your bands, if you have got documents, Landsat 8, then Landsat 8 2013, you have to make sure you go to documents and navigate until you reach the final folder that contains your bands, not other folders. To the final folder that contains your bands. So select folder. So there are our bands. Our bands have all been added. You can see band 1, band 10, band 11, band 2, band 3, band 4, band 5, band 6, and so forth. So those are our bands. Now we need to what we need to do now is to add. So you have to select an MTL file. This is a metadata file, right? It contains information about this Landsat 8 image. So it contains information about this Landsat 8 image. It has got a lot of variables there and so forth. So you have to select that. Then it will take you to the folder that you selected earlier, and then you choose MTL. The file that has got MTL at the end, or a file that has an MTL extension, say open. So it has been opened. So in order to determine surface temperature of a water body or of anything, is it an urban area or land surface temperature, using Landsat 8 image, you need to remain only with two bands. That is band 10 and band 11. So those are the two bands that we use to calculate or to estimate surface temperatures. We can remain with either one of them, but those are the two bands. They also almost give similar results. So remember, this is our here is our band 10, and here is our band 11. So we only want to remain with band 10 and 11. So we're going to remove every other band. You can drag and then press finance, or you can remove them one by one. So we have remained with band 10 and band 11. Then finally, don't forget to select brightness temperature in Celsius. There it is. And then you say run. It will take you to your folder. Then try to put it in a different folder. So here we're going to say surface temperature practical. So we're going to save it here. Comma. Select the folder. It's going to run. It has finished. Alright. So let's first check the values that we have here. They are supposed to be almost similar. As you can see, this is in degrees Celsius. So this is band 11 and this is band 10. So band 11, the lowest temperature is -2. The highest temperature, the lowest temperature is -25 degrees. I told you it's a cold area, this one. The lowest temperature of this water body is -2. Then for this one, the lowest temperature is, the highest is -1. Then the lowest is -26. So I think it's good that we use band 10 instead. This is 10 instead. So let's see how the temperature of the whole image looks like. So you go to single band pseudo color, then you come here and say you right click on top of the color ramp and go to create new color ramp and look for CPT city and say okay. So you look for temperature. There is temperature in Celsius. Say okay. Say apply. So redder colors, whiter colors are areas with the higher temperatures. Areas that are bluish, areas with lower, colder temperatures. For instance, here there are forests and it's towards I think it's towards Siberia, towards the Urals and so forth. So that side. So here is our temperature map of this image, but we're only interested in the temperature map of the water body, right? So we need to use that boundary we created earlier to clip this water body. So raster. So you're going to add your water mask now. It's a vector, right? Go to vector. You looked for comma reservoir. If you don't know how to determine a water mask, check my previous video. Thanks. So here's our water mask. You only want to remain with the water body because we're interested in the temperature variations dynamics of this water body. So raster, extraction, clip raster by mask layer. So your input layer is going to be your raster, temperature raster. The mask layer is going to be your water body boundary. Then you just say run. Okay, now we have our clipped temperature raster. It now shows the temperature of the water body only, not anything else, everything else. So properties, single pane grace, single pane pseudo color. Then you come here, right click, create new color ramp, CPT city, okay, temperature, then temperature in Celsius, then apply. So you realize that areas that are whitish, areas that have got higher, very, very high temperatures. Then areas that are greenish, they've got much lower temperatures. So if you come here, I told you that there is a we're supposed to see higher temperatures around this area where there is a hydropower station. So in this area we've got PEM hydropower station. I wish I had internet connection so that I can show you using from OpenStreetMap. There it is. So here it's called Pemskaya GPSC, means Pemskaya hydropower station. So this is, you can see power lines. So this is a hydropower station. So, and around this area we've got what? Very high temperatures. If you can check here, around this area, temperature is 4.7 degrees Celsius, but in other areas it's negative. But here, where they generate electricity, it's 4.6, 4.7, 4.4. So we've got higher temperatures there. We also have higher temperatures this side. I think it's tepid water or something like that, but it's negative still. So what we can do is to check positive temperatures. Where we have positive temperature, we can come here and say maybe first let's say 0. So we only remain with this area where we have got our hydropower station. See, it's the only area that has got positive, very high temperatures, abnormal temperatures. We're expecting to have negative, since it's Russia and it was a cold month, but we're having higher temperatures here because there's a hydropower station. All right, guys, that's how you calculate, estimate the surface temperature of a water body, but you can also use the same method to estimate the surface temperature of anything. Is it an urban area, to determine what we call urban heat islands? So it's also a potential project for students. Maybe you want to determine the hotspots of heat in an urban area. You can use the similar procedure using QGIS, Landsat A. This is your boy Cobes, the GIS analyst. Have a good day.